So the today's topic is Apache Pig. So let me explain first thing what is Apache Pig. Apache Pig is also known as data flow language, or we can say transformation language. Okay, so these are also known as data flow language and transformation language. So let me explain why it is known as the data flow language and transformation language. So, and Pig is one of the component of Hadoop, which is built on top of HDFS, Hadoop Distributed File System. Okay, one moment, do some recording. So on the top of HDFS, as you know, and it's a high level language. So how it is a high level language, I will let you know. High level language over map reduce. Okay, so as we are aware about MapReduce, the code which we are written in MapReduce, it is purely on Java code, and everything we have to define there. Like if I am going ahead to some of the numbers, so we have to write some of the codes like A is equal to B and B is equal to C, like that. So we have to write each and every course and as per the class. But it is a MapReduce is known as the low level language. It is a low level kind of language, but Pig is a high level kind of language. Why? Because in Pig, whatever the codes we are writing in MapReduce, if it is around 200 lines. Take an example, if it is 200 lines, so same thing in the Pig. If I'm using the Pig, we can write in within 10 lines. Within 10 lines, I can write it. So with the help of transformations or in built-in transformations in Pig. So what transformations here? So like take an example, load, and these are the many transformations in Pig right now. So I will tell you around 15 to 20 transformations in Pig, which is basically used infrequently. So by this way, by the base of this transformation, this is the execution time is very less as compared to MapReduce. If we compare the execution time of Pig, it is very less as compared to MapReduce because number of lines is very less in Pig, and as per the Pig, it's we are using the transformations. That's the data flow language as well, which is known as data flow language. So it's very less execution time is there. And one more thing you should remember: Pig is Pig is meant for processing. It is meant for processing only. It is not meant for storage here. So we are writing the scripts in Pig using the built-in transformations and to analyze the data to clean. Let me write here. Pig is used for data cleaning and data, or we can say, or data scrubbing. Okay, so it is like scripts. So by the help of the Pig, we can able to clean the data or scrub the data. As we have already seen in the demo class, like whenever I am getting the data from different sources, first we should clean the data, then go ahead with process. So by the way, if I get the data from in HDFS, okay, first you have to put this data into HDFS, and using the Pig, you have to clean this data, and after cleaning of data, you have to go ahead with Hive or any other ETL tools for the processing purpose. So this is the way, this is the chain. HDFS, Pig, and Hive came into picture for only these three things. Okay, and if you go ahead like visualization, I want to just visualize our data because it is a millions of records, so we can't able to go ahead line by line to check the proper contents. So for that, we are using a BI tools here, which is known as Tableau. Tableau is basically used for visualization of data in terms of chart bars like that. So this is the way of using these tools. So now I'm dealing with Pig only. I'm not worrying. We have already done with HDFS. Now I'm dealing with Pig. Then coming back to Hive as well. So now I have discussed what it is used for cleaning of the scrubbing of data. So now coming back, as we are aware, Pig is exclusively means what do you mean by exclusively? Exclusively means not built inbuilt, we can say, not inbuilt with Hadoop. It means we have to externally one of the files of the pig we have to download and we have to set up this pig on the top of Hadoop. Okay, so this is the way exclusively meant for processing, as we have already written somewhere, of huge volume of different varieties. As you are aware about the different varieties means a structured, semi-structured, and unstructured kind of data. Okay, so different varieties. If we talk about pig deals with structured and semi-structured kinds of data only. It will not pig will not deal with unstructured kinds of data. What does it mean? Pig, whatever the ETL tools we are using here, that is known as Apache Pig, which is dealing with the structured and semi-structured kind of data. It means they can able to deal with the tabular data, like in terms of rows and columns data, and they can also deal with the JSON data, logs files, and we can say XML files. These are the kinds of semi-structured kinds of data. They can able to deal with this exactly means we can able to Pig is able Pig can able to deal with these kinds of data. But whenever we are talking about videos, audios, images, these kinds of data, Pig is not responsible for that. Pig will not capable to process that data. So this is the drawback with the Pig. So who can process these unstructured kind of data? So in that case, MapReduce came into picture if we need to process the unstructured means unstructured stands for means audio, video, images, these kinds of data. With the help of MapReduce, we need to process this unstructured data with the help of MapReduce only. Okay, so these are the overall descriptions, or we can say overall definitions of the pig. Okay, now coming to notes. Some of notes you have to remember. Note first. So what is note first? Even though the processing happen through multiple inbuilt transformations. So what is transformations here? We will see some of the transformations which is using in Pig, and we will also see some of the examples using that transformations, how to load data, how to filter it, how to group by, how to dump the with the help of these transformations. We can able to see after completion of this topic. So transformations, multiple input operator, we can say it is like operator in Pig. Behind the screen means behind the screen means internally what is happening internally. These inbuilt operators will convert into MR jobs to get the desired output. So what does it mean? As I told you, MR MapReduce is the core component for the processing in Hadoop. So whatever the jobs we are triggering from the ETL tools like Apache Pig or Hive and many more the ETL tools we have. So whatever the jobs we are triggering from anywhere, that jobs breaks into the internet into the MR jobs to get the desired output. So this is the main intention, or this is the note point there. So don't confuse, Pig has its own jobs like that. So internally it breaks into the MapReduce jobs only. So now coming back, The next topic is where to use MR and P components in real-time use case. Like you should ask, we have the map reduce, and map reduce can able to is process structured, semi-structured and unstructured kind of data. But why we are using Pig there? And as you know, why we are using, because of the execution time, because Pig has a lot of transformations, so that's why we are using Pig. That can be able to dealing the handle the structured and semi-structured kind of data. But the thing is, MapReduce is can able to process all kinds of data, all different varieties of data. But on which cases I have to go ahead Pig and go ahead MR. So let me explain. MR and Pig, Apache Pig, we can say it's like short form. I'm setting Pig are exclusively meant for processing part of data. In the below real-time use cases, generally big components are not recommended. So for which purpose or for which cases we are not recommended with big. So let me explain first case. What is the first case? When unstructured, I told you earlier, when unstructured data processing is involved. It means if there is any unstructured kind of data, so we cannot go ahead with pig. Pig is not capable to process that unstructured kind of data. Second, when hierarchical job processing is involved. If some hierarchical jobs are processing involved, like I am dealing, let me explain you further. Like here, like Pig, Hive, and some other tools are there. So what happened? So I am getting. So, okay. So let me explain what is the structured data. So like tabular data, okay. And what is semi-structured kind of data? So we can say logs, okay, XML, and one more we have many more JSON. So etc. These are the kinds of semi-structured kind of data. And if we deal about unstructured, so like audio, video, images, these are the unstructured kind of data. So like I'm just going heaven hierarchical jobs processing is involved. It means I am getting like Pig is not uh, a big component is not recommended when there is a hierarchical job processing are there. So take an example. I am getting the data from different jobs. Like one is the Pig, one is the Hive, one is the other scope, like that. So whatever the output of one job is the input of the another job, and the output of the another job is the input of the other job. So like that. So this is the hierarchical jobs, hierarchical process. So at that time, Pig is not involved. Pig is not recommended for that kinds of executions of that things. Okay, so now coming to the third point, while we are expecting more performance, if we want more performance, again, okay, if we want, because everyone is talking about performance of any jobs, like I'm executing one of the, I'm triggering one of the queries, or I'm triggering one of the jobs. So what is the performance gain there? So how much time it is taking, or what is the execution time? So these are coming under the performance, we can say. Compared to Pig, MR is always have edge, because whatever, because if you compare the performance with MapReduce as compared to Pig, so MapReduce is always have edge because of whatever the jobs we are, whatever the transformations we are dealing in Pig. So in the back end, That transformation will convert into map reduce jobs to get the desired output. So that's why again it convert into the map reduce only. So that's what MR is giving. MR is the has a lot of performance as compared to Pig. So MR method is giving better performance as compared to Pig ETL tools. So this is the way where we use the MR and Pig components in real-time use case. If someone asks you, can you please differentiate between the MapReduce and Pig Apache Pig ETL tools in real-time scenario, you should have to tell these things. You should have to tell these three things where we cannot recommend the Apache Pig components. This is the way. If I have this requirement and I know this, the processing is like that. I have unstructured data. I have hierarchical jobs. I have talking about performance. So at that time, we are not dealing with the pig. We have to deal with the MapReduce only as compared to pig. So now coming to the different modes of pig executions. So like as you know, there are two types of file system we have. One is the local file system, one is the HDFS file system. Okay, so now coming to the modes of pig execution. So there are two modes of pig execution. So what is that? One is local mode and the other is HDFS, or we can say MR, or we can say cluster. So all the name, whatever, if we can, I can also say HDFS mode, I can say MR mode, that is a MapReduce mode, I can say it is a cluster mode. So these are two ways of mode we have in Pig executions. What is the local mode and what is HDFS mode? Let me explain first. So what is local mode? So in this mode, Pig will accept the input data from one of the local file system. Local file system, we can also say LFS. LFS stands for local file system. Okay, once the processing done, because we are doing some processing there, some analysis here, some data is coming or data cleaning here. If it has been completed, it will produce output. It will produce output in LFS only. So in local mode, what happened? If I am using the pig in a local mode, so I can pig will accept the data from the local modes only, and it will after execution it will store the data, it will store the output data in the local file systems only, not dealing with the HDFS. So same as it is in HDFS, here pig will accept the data from HDFS path, and once processing done, it will produce output in HDFS only. So you understood. If I'm talking about local, so there's a local file system. It will accept the data, input data from local, it will produce the data into local only. And if we talk about HDFS mode or MR mode or cluster mode, so it will accept data from the cluster mode, that is HDFS mode, HDFS path. And after processing, one processing has been completed as per the script we have read in the pig, and that has completed, and it will generate some output there. So that output data will be placed somewhere in the HDFS path only. So these are the two ways we can go ahead. So how to execute? So with the, if we talk about local mode, how to go ahead with execution of pig. So you have to give on the terminal pig -x local. If you give this command on the terminal, one of the shell console you will get, I will show you, you will get, that is known as local current shell of pig. In the HDFS mode, if I give only on the terminal like pig, so what will happen? You come to console with grunt like that. So it means if I deal with only pig without any -x local, what happened? I am dealing with the HDFS or MR cluster mode, not the local mode. So whatever the files we are putting or loading there, so we have to load from the HDFS only. We are not loading from the local file system. If you are dealing with HDFS or MR cluster mode, if you give the load path from the local file system, it will throw an error. So I'll let me explain these two things how we can go ahead. So I'm just sharing you the terminal here. So this is the terminal of Cloudera Hadoop. So I'm just dealing with the local file system. Local means local mode, pick local mode. So let me type this command local. So it is executing somewhat is a configuration related file that is only duplications means somewhat the aberrations already here. So we have to update that all things. So no worry about this warning and these prompts. So it will like see you can able to see this grunt here, right? Grunt. It is the local console of Pig. Now coming to Control Shift T, you can able to another tab or terminal. In that I'm just giving Pig only. You'll see. Okay, so I also see here the grunt shell here, right? This is a grunt shell. So I will let you know what is grunt shell and all these things. So here, this grunt shell, this console of the Pig is for the MR or SDF is a cluster mode, not in the local mode. It is a cluster mode, and this one is for local mode. So we have already two environment here. One is the cluster mode, one is the local mode. So come back again to the notepad, and one more things you have to write HDFS mode, or we can say cluster mode or MR mode is not development or test mode. It's a production mode. Means if you are dealing with real-time cases or real-time use cases, so at that time you have to deal with this mode only, not for local mode. Local mode is meant for the development mode for the testing purpose or for the unit testing and all. But if you deal with the real-time scenario and there's a productions, so you have to deal with the HDFS or MR or cluster modes only. So this is the way I can configure. We have seen about the different modes of Pig executions right now. So coming back, different ways of running Pig program. So what is that? Means we can run the Pig program in the how many ways? So first is grunt shell. First is grunt shell. Second is script mode, and third is embedded embedded mode. So this is the three modes we have. So by these three ways we can able to run the our Pig program whatever we have to write there. So first one is the grunt shell. So let me show you what is grunt shell here. So you can able to see here, if you come back, whatever I have opened here, it is the grunt, right? So here the grunt is written. So it means whatever the commands we have given first, pig hyphen x fig happen x and with local. So that is the local mode. I got this grunt shell for the local mode. This is known as grunt shell. Here we can write our transformation of the pig. In here also you can able to see for the HDFS or clusters mode also have the grunt shell. And what about this? uh, Coming back to script mode. So as you are aware about the shell scripting, what happened there, what is the requirement? As per the requirement, we have to write all the scripts. Instead of writing one by one in the terminal, we have to gather all the information, all the commands, all the requirements. As per the requirement, we have to just write all the commands in a single file in .sh file, and we have just triggered it in a one shot. It will in a one shot. If I trigger that file in one shot, all the process happen. Same way here in script mode, because the grunt shell whatever we are working there, now I will show you. So that is a console based we have to write one by one. So that is not a good way to write to work on the big Apache ETL tools, Apache Pig ETL tools. So better way is script mode. Whatever your requirement, as per your requirement, you have to create your script mode file. So how to create? With the help of file name, any file name you have to give, and the extension should be .pig, file name with pig. If your file name like this, okay, so you can able to run that pig file, and you will get the output all over the process in a one shot, single shots. So I will let you know how to create the script mode there. And now coming to the embedded mode, what is that? So as I told you, in pig we are dealing with many multiple inbuilt transformations there, multiple inbuilt transformations there. But the thing is, but the thing is if we but the thing is if we don't have the transformations like inbuilt transformations, what I have to do there, and we don't have the inbuilt transformations, like we don't have inbuilt transformations. Okay, so at that time we have to create our own transformations. Okay, we have to create our own transformations with the help of Eclipse tools, and write the code in Java. And after that, create jar file and add this jar to big script file. So this is the way. Suppose it is a very rare case you have to go for the embedded mode, because I'm telling, because very few cases you will get in a real time where that transformations, like we have around 90 or 70 80 transformations right now in the pig, which is already available. So that transformation is enough for the use case or real time projects. But sometimes it happens like whatever the transformations we have, that is not enough, or that is not available as per my requirements. We do something new. So what I have to do, as per my requirement, we have to write our own logic in Eclipse tools with Java code, and that after the completion of that things, we have to create a jar file, and that jar file should be embedded here in the big script file, and we can call the functions and all, and we can get the transformations. It's like your own UDF, we can say UDF, user defined functions, or it's your own transformations here you can use here in embedded mode. But don't worry about the embedded mode, because it's very rare case. So you are not worry about these things, because some guys should be there. If you have the requirement as per the real time scenario, so you should check with your team. Some guys should be there who knows, who is expert in Java. They have to create this kind of transformations, because you are a ETL developer, so you have to worry about these transformations, which is already inbuilt transformations there in that pig. So I hopefully you got these the different ways of running pig program. First, a grunt shell. Second is script mode, which is like file name. We have to create a file. Inside that we have to write all the transformations as per the requirement, and save the file as a .pig extensions, and run that pig extensions file. I will let you know how to run it. And third one is the embedded mode. It's like whenever I don't have any available transformations into transformation in pig, so at that time we have to create our we have to create our own transformations, and create the jar file, and add this jar file into our pig script file, and get that expected output. So this is the way of different ways of running of the pig program. So now coming to some of the transformation in inbuilt transformation in pig. So what are the inbuilt transformations right now in pig, Apache Pig? So let me explain you. First transformations you will get here, load. Load. So like I have data in local file system or HDFS file system. So first requirement, you have to load data first. So for that you have to use the load transformations here. Second is for each, and third transformation is generate. Fourth transformation is filter. Fifth transformation is dump, and sixth transformation is store. Seventh, describe. Number 8 transformation is split. We have to split the data as per the file, and order by. You are aware of this in SQL. Order by. I hope so. You are aware of this thing as well. Group by in SQL. You can use there also. You can use here as a transformation, and join. And I'm telling you about union. We just do union two in the two data sets here. Okay, and limit also there. Limit is the transformations here, and also we have many more transformations like distinct, and one more transformations I am just giving you aggregation transformations like sum, min, max, average. So these kind of transformations we are getting in the Apache Pig nowadays.
So are those a kind of like similar function like we use for SQL?
Yes, exactly. So like you are using the load there, right? In simple, have you used anywhere load?
Not really load, but the order by, group by, join, union,
Yes,
limit,
yes,
district, aggregate, store.
yes,
These
yes.
all functions are there, I think, in
Yes, yes.
SQL.
So these kind of functions also here we can also use because we are dealing with somewhat tables data because that is a tabular
Okay.
form data. So if I just want to join two tables, so you can use the joins. Okay,
Mm,
with the help of joins, I can join the two tables. But the thing is, if I'm going to join that two tables data in MapReduce, we have to write around 200 lines of code because there is no transformation right available in MapReduce. So here is the transformation is join. If I want to join two union two data sets, data sets means I have two data sets I have in my STFS. I just want to union it means combine it. So with the help of union, I can just concatenate or like that. And I just want to max and mean like this all transformations what were written here from 9 to 15. This all you can able to see in the SQL as well. Okay, so these kind of
okay.
transformations we have used here. So like these are 15 transformations. Many more are there, but I'm just not explaining for that because it's 70, 80 transformations here. So whatever deal with, I'm just written here this 15 transformations. So which is frequently used in the big script. Okay, so now coming to the split versus filter. So what is that split and what is filter? So let me explain first. Coming back to split. So sorry, filter will always produce one file, one output file we can say only. Means what he's saying, whatever the huge amount of data I have, whatever the huge amount of data I have, if I go with filter command, like we're filtering some data with that huge amount of data, so whatever data it will generate after filtering, so it will generate only one output file. Okay, so now coming to split. Split, as per the name itself define, split means we have to split the data in two files. So split means split transformation. We can say it is a kind of transformations only. Also generates or produce minimum two files. Okay, two output files. We can say minimum two output files. So you understand? So splits generate two output files minimum, but filter will generate only one output file. However, the data set is very huge or like that. so it will not take care of that data set's capacity or volume. It will just taking care of only one file it will generate. So if we talk about this, so who is better as per the performance? So as per the performance wise, split transformation is better as compared to filter. But users, as per the users, we have to uh, compare like which filter has its own properties for filtering the data, and split has its own properties for splitting the data into two files and give the parallelism and very less execution time for accessing or analyzing the data like that. So here also these are the two difference between these split and filters. So now coming to, as we are aware, like MapReduce, and we have discussed about HDFS. So as we have seen, MapReduce is also a processing tools which has its own data type, like int writable, long writable, float writable, is text, boolean writable, null writable. These are the data types we have seen in the MapReduce. So in Pig also it has its own data type. So let me explain first. One moment. So we are talking about data type here. So normal language, like we are talking about Java or something like that. Let me add it here. Normal language data type, and we are talking about big data type. So coming back to normal language type and big data type. So normal language data type, I have integer which is defined by int only. Here it is also int in big. If I have a string, that is a text format. So we are using text there. In Pig, only the difference is with the string only. You have to use char array. Char array is one of the data type in Pig. You have to use, instead of a string, you have to use char array. If you talk about float, so here also you have to use float here. So for each and every, only except a string, every data type is same as for the normal language in Pig as well. Double means here also you can use double. Long, here you can also use long. So like that data types we are using here. So how these data types I have to use, I will show you when I will cover one of the examples in Pig, like how to load data, how to define the schema of information, how to filter it, how to display data. So these kind of examples I will see in this class only. So now I'm just going ahead to discuss some of the examples in Pig. So let me go ahead with this. Ubuntu. So I'm just worrying about this Pig happen X local because our data is in local here. So let me zoom it first. Okay. So I'm just opening a new tab, and first I have to see any data here. Can I take this test.log? Okay. So no, it's not like that. Can I take it ls employee.txt? Okay, yeah. So I can go ahead with employee.txt here. So in employee.txt, one of the file is there which has the employee details here. So like first one, we can say it is a ID, employee ID, second is employee name, and second employee locations. So this has terminated. The fields has been separated by tab. The fields has been separated by tab only. So if you want to see how the separation is there, you have to use nano employee.txt enter. So if you have given backspace or delete one times delete, so you can see the, and you can give the back tab, so the table is like that. And if you give backspace or yeah, backspace or delete, so it's combined and you give tab here. So as we know, these fields like one field, one column, second column, and third column, this column is also known as fields. This field has been terminated by tab here. So I have the schema as we know. What is schema here? ID, which is integer, name, which is a string. In Pig it should be char array, and it is also a string, it should be char array there. So let me load it first. Okay. So yeah, so I'm dealing with local file system. So how to load this data? First question is, so I'm just loading these with the help of creation. First, we have to create a variable. So I'm just creating a variable data underscore employee. We are just dealing with the employee data. So data underscore employee. And here I'm just worrying about the load data. So you have to use load transformations here. LOAD load. And in single code, you have to give the path. What is the present working directory? PWD stands for P for present, W for working, D for directory, present working directory. This is the present working directory where the file is. Copy this and paste it here. Okay. After this, what is the file name which I'm going to load here? This is the file name which I'm going to load there. Copy this and paste the file name there. Okay. Using. Okay. You have to use using Pig. P should be capital and S should be capital. Remember this point. Pig storage and give fields terminated by tab there. As I told you, what how the fields is terminated. This is the field terminated ID with name. It is separated with tabular. So this is tab there. Okay. After that, we have to define the schema as ID. ID, it is integer. ID colon int. Okay. After that, name. You can able to see the schema relationship informations. First one is ID. First one is ID. Second one is name. Third one is locations. So now second one is name. It is a string. So Pig will support char array. I have written somewhere right now the data type which is supported by Pig. You have to give comma here for separation of the second schema. Third schema is location, which is also char array because it is also a string there. And what you have to do, you have to give a semicolon here and press enter. You'll see. Yeah, the data has been loaded right now without any errors. It has successfully loaded. So dump command, there's the dump transformation is for displaying the contents which this variable has stored. So there's a dump command, data underscore employee, semicolon here. Now I have given enter, so we'll see this command has it's running right now. Okay, it is running right now. Map task initiated, executed completed. Okay, so that should be fine. Output successfully records in file temp, something like that. Okay, yeah. So I can able to see the data here, right? This is the data which we are dealing, which we have loaded in data underscore employee of the variable. So you can able to see 123 Shahbaz Hyderabad. You can able to match here. First record has 123 Shahbaz Hyderabad. Second is 124 Arshad New York, and third one 125 Suhail and New York. So you can able to see this data. So okay, that should be fine. I can able to load the data and I can dump this data. I can display it. So that is fine. So you have to press Control L for clear the screen. Now coming to, I just want the data who belongs or whose ID is okay. So let me create a new data sets. Let me create a new data sets. Nano employee dot log. And I'm just creating a employee related informations like in first one is employee ID 10101 with pipeline delimitations. We are using the delimitation of five fields terminated with pipeline here. I'm giving healthcare. One of the organization is healthcare, and his salary is around 20,000 like that. And he's from New York, NY we can say 10102. And we can say he belongs to Infosys. One of the organization is there, and his salary is around 30,000 like that, and he belongs to New Jersey 10103. He belongs to some Wipro. We can say from where I'm belonging, 50,000. Okay, and we can say NJ instead of NJ. You can say Canada. Canada. We can say CA and ATA like that. So I have three data sets here with the organization's name with his salary, with his locations, where he belongs, his locations. So let me control X and press Y and let me enter. Now I can able to see this data in log. I can see this data right now. So my requirement is I just want to load this data into Pig. That is a local file system I am worrying about. So let me do this first. Okay. So I'm just creating a data underscore m. Okay, that's a variable. I'm just going ahead and we have to load the data with the help of load transformations. In this semicolon single quotes, you have to give pwd present working directory here. You have to copy this. You to have to paste it here, and which files you are going to load. This is the file imply.log. Copy and paste it here. And we are using big storage. Okay, and the data is terminated or fields is terminated by, previously it is terminated with tab, now it is pipeline. So you have to use here, instead of tab you have to use this pipeline there, and you have to define the schema related informations. So first one, what is the schema here? ID, organization name, salary, and locations. Okay, first one is ID. ID is in integer and fine. Second is C name, we can say that is a company name. We can say it's a char array because it's a text or name. Third one, what is the third one is salary. It's a big int. It should be like big int. And fourth one is location. Sal, it should be big int. Okay. And fourth one is location. We can say locations. Okay, full location. And it should be also char array because it's a text type string type. So let me load it. Okay. Okay, big int is not supportable here. So instead of big int, we can go ahead with a double or something long. We can say we can go ahead with long. It's supportable. I hope so. Let me write it. So it then accepted because big int is not a data type in the pig. That's why it throws an error like big int. Okay, so big int is the data type of the hive. So you can use the long here. Okay, so the data has loaded successfully. So let me dump here. Dump data underscore m semicolon. Okay, it's running right now. Whatever we are dealing right now in the peak, that is a local mode, not in the SDFS mode, because I am loading the data from local mode only, local file system. Okay, so that's why we are worrying about the local mode. So I can able to see this data right now. We have three data sets, three records like 101, healthcare, 2000, like that. Everything is there. So you can compare these data sets as well here. This is the original data set which I am loading right now in the peak. So we have seen two transformations right now, dump and load. Now coming to filter. So how we can filter this data? So my requirement is I just want to know whose salary is 20,000. The filter is I just want to filter the data whose salary is 20 more than 20,000. So I know as per that because it's a very less data, three records only. I know okay as per the scene I can say 10102 has more than salary from this more salary 20,000 and 10103 has more salary that is 50,000. But if you are dealing with millions of records, you can't say with scroll down like that. So you, as per the logic, you have to write some filters, the filter transformations there. So how we write that? So let me go ahead. I can create a variable first. Whatever the transformations, each and every time you're using one of the transformations, so you have to store that data into one of the variables. So I am just saying filter underscore data is one of the variable I am creating here, and where the data, all this data, where is that data where I have loaded? I have loaded this m data underscore m. You can able to see data underscore m here. I have loaded this data underscore m. Okay, so moment. So I just want to filter it. So you have to create a variables filter underscore data is equal to filter. One of the transformation is filter data underscore m. We are just going ahead to filter data underscore m, which has contains all the data where we have loaded the data. What is the data? This is the data this variable contains. I just want to filter this data as per the requirement. So what is the requirement? By, so I have given salary, right? So what is the, let me check first. Sal here, right? Sal, okay. So filter underscore data is equal to filter, sorry, filter data underscore m by sal. Sal is one of the schema which we have defined while loading the data. So we are just going ahead with sal is greater than 20,000. Okay, so let me enter first filter data by like this. Okay, so encounter warning implicit like that. So let's try. Okay, so let me dump filter filter underscore data. So it is running right now. Stored records successfully like this. We are getting the message. Now we can able to see. So see, whose salary is greater than 20,000 I have given, I can able to get two records only here. There is a 30,000 and 50,000 as per the filtration of data. You can also see these data sets and you can able to say, oh, this is these two records should come while giving the conditions like salary is greater than 20,000. So I can expect this data, I can expect this record. So I'm getting here as per the condition, but it is a very less like three records here. If you are dealing with millions of records, so there it is very helpful to filter these kinds of data informations there. So one moment. So this is the way we can go ahead with big commands, big ETL tools. Now, right now, most of the projects are using the Apache Pig ETL tools for the data scrubbing or data cleaning. So let me explain you first. Like we are getting data from different sources. It means somewhat data from internet as well, somewhat data from web server, which is generating the logs continuously. That is streaming kinds of data. So what you understand, what type of data they are generating from the internet, that all data is meaningful data? No, right? So somewhat the data is there which is null, somewhat the data which is not a meaningful data. It contains null. It is containing that garbage data as well in that file. But I know that I need that data only, which I need to be analyzed. So for before that processing, I have to clean that data first. So like null record should be there. So it should not null record should not be there in that file which I'm going to analyze, because if it should be there, I will not give the expected analysis. Okay, so for that it will be impact for our results or our analysis. So for that we have to remove all the null records first. And take an example. If we have in the file 29 columns means 29 fields, schema informations we have. But I know I just want to deal as per the analysis. I don't want all these columns. So as you can able to see, I have here in that file three columns are there, four columns: ID, organization name, salary, and New York. It's very less, but in real time you'll get a lots of columns are there, like 30 columns, 40 columns, like in the file. So what do you think? You need all these columns records? No, exactly no. What as per the analysis you have to decide which columns you need for as per the analysis. If you take the one example of the airline data sets, so if you go ahead with that analysis purpose of the airlines data, so that airlines data around 29 30 columns in their data sets. Okay, I have seen that data sets. Okay, so that the data sets what they have, it is not all the useful data sets there, means column wise. So they need only 8 to 9 columns only as per their analysis, not all the 29 columns. So to which tools it's doing this scrubbing or cleaning the data due to the use of the big ETL tools only. This is the way I can go ahead with cleaning the data, scrubbing the data, remove the unwanted data from the source file system, input data after, and then go ahead with processing. This is a very useful uh, extract transform load tools we can say in real time. So this is the way I'm using the pig. So overall description what we have discussed till now, let me open the agenda. So till we have discussed about the pig, like what is pig, how the pig is working, and what kinds of modes and what is the map reduce and mr have comparison we have seen. And we have seen the different ways of running of pig. We have seen some inbuilt transformations, and we have seen some of the examples how to load data, how to filter it, and how to store like that dump. So these are the things we have seen till now. There's lots of transformations. So if I will share the development guide with you guys about the pig. In that development guide, overall the pig, like all these transformations uses there in that development guide, you go ahead and you with the solution, in that is there. Okay, so I will share with you. You can go ahead. You can able to understand what is happening there. So I have seen the split versus filter as well, and data types, and some examples we have seen. So till we have discussed about the pig here, and overall scenario, the pig has been completed till now. There is no more to discuss in the pig right now. So now coming to the Hive, one of the ETL tools which is known as Hive. What is Hive first? It's kind of data warehouse. It's the kind of data warehouse. So let me explain you first what is data warehouse. Then I will go further. So you are aware about RDBMS, right? Relational Database Management System.
Yes.
Okay. So there I am using. We are using like use MySQL, SQL Server, DB2, Netezza, and Teradata. These many tools are there in the RDBMS. And as we know, the capacity of the RDBMS is around GBs. It can up to store the GBs of data, not much more, right? But as we know, everyday data is growing and growing. So data warehouse came into picture for it can store up to TBs of data, terabyte of data. But what is data warehouse? So we can say instead of using the bucket, we can go ahead with drum, right? The capacity of drum is much more than bucket, right? Okay, so drum, instead of using the bucket, take an example, RTPMS is a bucket and drum is a data warehouse. We are storing the water in the bucket, and we are storing the water in the drum as well. So what does it mean? You have to buy a huge volume of hardware. On the top of hardware, you have to dump one of the MySQL RDBMS tools. You have to go ahead with SQL, MySQL. You have to go with Oracle. We have to go with any RDBMS tools. So what happened after dumping of that RDBMS tool on a huge volume of hardware? It becomes a data warehouse, and data warehouse is a totally a OLAP system. OLAP stands for Online Analytical Processing. So I have discussed this OLAP and OLTP system in the demo class, Online Analytical Processing. Okay, so this stands for data warehouse containing historical data only. Historical data means old data, not the current data or day-to-day data. So this is all about the data warehouse. So Apache Hive is kind of data warehouse, but it is not a data warehouse. Okay, so let me explain what is Apache Hive first. Hive is meant for manage the data in the form of table. In the form of table, we can able to manage the data. So in Hive, we are dealing with tables only. Like we have to create the table, we have to load the data into the table, then go ahead to write the Hive query language instead of a structured query language SQL. Instead of SQL, we are using here HQL, Hive query language. It is similar to the SQL only, but the name is different as per the internal structures as compared to the SQL. It is different. Okay, that's why we are saying instead of using the SQL, you have to use HQL. Okay, so we have discussed. Now, let me write some definitions about the Hive first. As we know, Hive is one of the component of Hadoop, which is data warehouse kind of system. I'm saying kind of system. It is not a data warehouse. Okay, it is a kind of data warehouse system exclusively meant for processing huge data sets. Okay, okay. Hive is meant for querying because we have to write some queries here. We have to tell like that HQL of the data, data summarization also here, summarization, and for advanced querying, we can go ahead with advanced querying also here. So we'll see what is it advanced querying here and data summarization and analytics of data here. So it's all about definitions about the Hive. So total overall we can say Hive is a kind of data warehouse system. It is meant for the managing the data into tabular table forms, and it is meant for processing. And we have to write the uh, Hive query language, that is the SQL for the analytic purpose. So it's overall description or overall definitions about the Hive here. So what is meta store? So let me tell you about one thing, meta store. So you heard about this. I have already explained about metadata here. Metadata. So what is metadata? Data about data. What is that? Means whatever the data we are storing in the SDFS, that is a Hadoop file system. So for that data, there is a master node known as the name node, which stores the metadata there for that blocks or the data which is storing the data node. So here also we are dealing with Hive. So Hive has its own meta store known as Derby. Hive has default meta store known as Derby. Okay, I'm just giving an overview about what is Hive, what is meta store, and what the kinds of tables we have to create in Hive. But in tomorrow, next coming upcoming session, we will see in briefly like Hive definition already completed, but we will see talk about the meta store in briefly and what kind of metadata they stores like as per the tabular format, and what is the structures of Hive internally, how the Hive's working internally. So we'll see in the upcoming sessions. And not coming to Derby. So Derby, it works on single node cluster. It is not for the multi-node cluster. So you have the question, yeah, if Hive has a metadata known as Derby, which is responsible to store the metadata of tables and all, but it's working on single node clusters only. But in the real time, we are dealing with the multi-node cluster. So here Derby, we can't use Derby here. So for that, there is external meta store we can install, known as any RDBMS tools. So right now, whatever the RDBMS tools we are using for the meta store in the Cloudera, which I have shared with you guys, that is known as MySQL. Okay, MySQL also known as RDBMS tools. I'm using here MySQL, so which is meant for the meta stores here, and it works for multi-node cluster. Understood? So this is all over about the meta stores we can say. Now coming to tables. So as you are aware, in SQL or in MySQL or in RDBMS, we have to write the query for creation of a table like create table and give table name there, right? And some schema definitions. That's it. No more information we have to give here. No more information we have to give here. So it will create the database or tables in the RDBMS. This is the way. But in Hive, we have dealt with the same commands, but there is some more information we have to add there. So we'll see what kinds of syntax there to create the table in Hive and what kinds of tables in Hive there. Like I will tell you, there are two kinds types of table in Hive. One is the managed table, and second one is the external table. So these two kinds of tables in the Hive. So inshallah we will talk in the upcoming sessions, means coming weekend, about this Hive only. So it will take around two classes. Next weekend we will discuss only for Hive only, because it's a very huge topic. Lots of agenda or topics in the Hive we need to cover. So and for the hands-on as well, it will take some time to cover this Hive, because it's a very huge topic. Hive, or we can say Impala. Okay, so these are the two. So whatever you are working in Hive, whatever I will teach you in Hive, same thing will work in Impala, but the interface we can say, or we can say graphical user interface for both are little bit different. But whatever the query you are can able to run in Hive, the same query you can work out here in Impala as well. There is no difference, but the internal structure of the Impala as compared to Hive is totally different, and as per the executions, Impala is better than Impala will give more performance, better performance than Hive. But right now, it doesn't mean like nobody is using Hive. Hive is everybody is using Hive right now, but it depends upon the requirement and situation as well. So I will let you know when I go ahead with Impala, when I go with Hive in the upcoming session only. So